Hey everyone, and welcome back to another CTF Writeup video. This is DeadSec CTF 2023. It was a 48-hour competition, and I would rate it as kind of intermediate difficulty. For this Writeup video, I'm going to be covering the following challenges: 2 from cryptography, 2 from Pwn, 3 from web, and then 1 of the welcome challenges. And with that, let's get started. The first welcome challenge just says, greet each other and welcome, you may receive the flag. For this one, the trick was just to go to Discord. And you'll see people passing this emoji around. And so if we go here, welcome, or this welcome, you'll see, thankfully, Abu Kazim is being very generous, and they're posting this quite often, but it's this Pepe meme. It's a little hard to see. So if you go over here and you figure out which one it is, I think it's this one. On the web app, you can right click and go to copy image location. We'll go here and you can delete these parameters, the size, and you should see it here. So you can wrap this in a dead, and that was the first flag. The first web challenge is Crush. We're given a URL and a download file. This is what the website looks like, and this is what the source code looks like. For this, we were supposed to be doing a prototype pollution. And so if we look at the win condition, it's down here. It tells us that flag is in flag.txt. And in this route, there's 2 different calls to fs read file, and either we need to be able to pass flag.txt into read and then the key letter name, or into read letter name, where letter name is a variable. So I think there's multiple ways to do this, but thankfully they kind of hint towards prototype pollution up here. They define this function, this set value function, and you can see they're kind of doing this recursive object setting. And so we don't say anything that's specifically bypassing the proto object. So most likely we can overwrite that. And prototype pollution is also kind of implied because if you read through the source code, they use these 2 global variables, both letter and read, in kind of in different contexts, but really you kind of want them to be equal. You want control of the other one, and thankfully using prototype pollution we have control of one, which gives us control of the other one. To actually do the prototype pollution, they gave us this route called hacking, and here if this hacking parameter, so we get to pass 3 parameters: hack, letter name, and rename. If hack is equal to rename, we get to do the prototype pollution, where we have a key and a value. So looking at the solve script, this is what I ended up doing. Let me copy out the URL. First, there was a call to reset. I don't think this is necessary. I just like to have a clean slate as I'm building stuff. So reset will delete both objects. Where is it? Hack equals reset. Okay, then the read object will be deleted. So I just use that to have a fresh start because it took me multiple tries to get this correct. Then we do the prototype pollution. So again, we're calling that hacking route. And so we're going to use the rename. So that's how we can set a key to a value. We're going to set the proto key on an object. So we're doing that prototype pollution. And we're going to set it to the object flag.txt is equal to ... up flag.txt. And so this means that pretty much any object will have the key flag.txt ... flag.txt set. And so this is useful. And then after that, we're going to request read letter name is equal to flag.txt. And so what's going to happen is we're going to call this. And since that key will always exist, flag.txt, it will not be equal to null, it'll be equal to here. And normally it's only defined on letter, but because of the prototype pollution, it'll exist on every object, including read. And so now read letter name will have the correct letter name, which will be flag.txt, and this will return ... up flag.txt. Oops. And this should give us the flag. It'll just return the flag file. You had to guess a couple of times. It says it's in flag.txt, but you need to go up a couple directories, and you can just find that from just kind of guessing around. And yeah, we can run it. Let's make sure it's still working. Let me save that. Make this a little bit bigger. Let's do Python 3, solve.py. And there we go. The flag was dead. Crush loves you too. The next web challenge is XEE1. It says flag is in flag.txt, and we're given a link. So if we open it up, we're given a login form. We can type in some garbage, see what it does. Nothing. It says log and fail. We do get reflected content, which is interesting. If we look at the network request, we can see that the request payload is actually XML. And if we think about the challenge, actually, and the title says SQL, And if we look at the challenge name, it was XEE. There's an attack called XML external entity injection. Normally it's XXE, but I guess maybe it could also be XEE. Either way, that looks like a good target, and that ends up actually being the exploit we're going to do. So we're going to try doing a XXE attack on this web form. And so basically what we're going to do is we can supply kind of like these custom types that an XML parser will execute, and using that we can read files off disk and do some other clever stuff. You can try doing SQL stuff, but you'll quickly find that there's no SQL injection here. It's just this XML attack. To actually solve it, it took a couple of different steps. The first thing to do was kind of prove to yourself that it was actually doing an XXE. And so what you can do here is we're going to define our payload. So we copy the previous payload. It was just user, username, password, password. It showed us earlier that admin was a correct, if you look at the source code in the JavaScript, it says admin's a valid password, username, password. And so we know what the response looks like. It should say like status code 1 or something for successful. So first we're going to try and seeing if we can do a simple replacement. And we're going to replace this @replace with the string admin. And this is just how you can do it using these this doc type and this entity. And so when the XML parser executes this, this should, instead of saying to replace, it'll say admin. And so if that works correctly, we should get a nice response back. Oh, and the rest of the code you can see, I'm just doing a post request to the login and I'm specifying it's an XML type. And so this is just to prove that we actually have a external entity injection attack. And we can see we get code 1 back and message admin. So it looks like we were successfully able to log in as the admin user, and so because of this, we know that this external entity injection attack works. From there, we should see if we can load files. So you can do this replace with a system file. So we're going to see if we can load a known simple file on disk. And if we can, and thankfully it reflects the username, so we get that content reflection. And we can see, yeah, we get the user password file. So super useful. We can see that there's a root user, whoops. There's a root user, oh, it's being weird, and a onsra user. Cool. Next, what I did is you can also, using PHP strings, you can load resources. You couldn't directly drop the flag for some reason because you're just getting a weird message. It said something about like dead can't be in the flag or something like that. So it looks like they're specifically looking for the flag in the response, but you can request what the source code looks like on disk, and we can base64 encode it so that if there is anything special with it, it shouldn't be filtered out by base64. So we're going to specify PHP filter, convert this resource into base64, and that way we can see what it looks like. So we're going to request login.php, Python 3 solve. And this is the response. So this is the base64 of login.php. So if you do a base64 decoding, you'll get this. So this is the code that is running on the remote server. And we can see it's doing pretty standard. It's gonna, the username, password, this is the default. This is nice, disable entity loader. This is the actual vulnerability. They specifically turned it off for us. And here was something we were getting caught on earlier. So if you request specifically the flag, it'll return this dead, and since this is matching, it'll say you can't read the flag. So that's too bad. But using our base64 trick, we can just encode the flag with base64, so the username is a base64 of the actual flag, and from there it should just work fine because the base64 won't match the keyword dead. And so we do that. We base64 encode the resource flag.txt and send it over. Oops, too far. Python 3 solve. And there we go. This should be it. So you can take this and you can do a echo, and we'll do base64 decode, and there it is. Nice, bro. XEE easy, haha, or hee hee. So fun. The next challenge is web Bing. We're only given a URL. At the URL, there's only one web form, and here basically we type in some stuff, and in the back it's going to do some sort of shelling. And so the goal of this challenge was to get command execution. To do this, they heavily filtered a bunch of different keywords. If you play with it for a while, you'll realize you're not allowed to use spaces, and there's a bunch of special characters you can't use. You can't use certain commands like cat, but you can actually use tac. And actually, I think I have an example of this. You can specify, so this is just the request that form makes on the front. So you could do tac etc password, and you pass in etc password this way, and that actually works. This is Bing, so Python 3 solve. And so you can see we get back the etc password. But if you were to do cat, it gets mad. If you do ls, it gets mad. Instead of using ls, you can actually use du. I think this is disk utility. So you can see some stuff that exists. This tool gets the file size or the folder size of different things on disk. So there were a couple of tricks to kind of play around. Eventually, to make the exploit reliable, I think that maybe the hardest hurdle was you're not allowed to use spaces, but there's a decently well-known trick in CTF, so you can use this thing called the environment variable called IFS. I think it's internal field spacing or something like that, and this allows you to have spaces. So we can do echo and then IFS, and so this will place a space there. Since we're not allowed to use spaces, what I ended up doing is passing all my commands that I want to execute as base64. So first I generate a command and I base64 encode it. And then on the other side, I pipe it. So I echo my command, then I base64 decode it, and then I run it in shell. And basically this little gadget allows us to run anything we want remotely. And from there we can quickly find the flag. So you can type anything you want in here. You just ls around. It doesn't like it. There's again, for this challenge, I think it's looking for some part of the flag string, and if it contains the flag string, it gets mad. So as long as when you retrieve the flag, you just need to base64 encode it, so that way it doesn't get too mad at you. But yeah, that was pretty much the challenge, just figuring out this IFS thing or some other way to get rid of spaces. There's probably multiple solutions to this, and then base64 encode the flag when you send it back because there's some sort of egress filter looking for it. And yeah, this should just give us the flag. So we'll do, going on Python 3, solve that flag. Solve.py, and we get this back. So we'll echo this, and we'll do a base64 decode, and there we go. Dead, okay, this flag for you. So fun. The next two challenges are loud and really loud from the cryptography section. During the CTF, there was a revenge set of challenges, loud revenge and really loud revenge, which were released. And then there was another revenge of the revenge, which was LLL loud and LLL loud 2. I think this implies that we were supposed to be doing a lattice reduction attack for these, this LLL algorithm. But I ended up just brute forcing it, which I think is what most people did for the first two at least. And so I'll be talking about those solutions. For these challenges, basically what's going to happen is this is the kind of the challenge script. They're going to generate a list of primes. So for this one, they're going to generate 30 primes of bit length 1024. And then they're going to give us some information, and they're going to give us a bunch of groups of information. And in this group of information, there's going to be, for this specific challenge, there's going to be 4 just kind of random numbers, and one number is going to be the flag modded by one of the primes. So again, we're going to have an array of 30 groups, and in each one of these groups, there's going to be 5 numbers. 4 of them are random primes, and one of them is the flag modded by a specific prime. We know what the specific primes are. Thankfully, those are given to us. But in each group of 5, which one is the actual flag modded by a prime is unknown because they're going to do this little shuffle thing. Cool. So to kind of cheese this, thankfully the numbers they give us are very large. So the maximum size of the flag is just some random number between 0 and 2 to the 2048. Since the primes that we're modding with are also very large, we can actually just brute force it using the Chinese remainder theorem. If we guess the wrong number and we Chinese remainder theorem it, most likely the resulting Chinese remainder theorem is going to be very large. It is going to be outside the bounds of what's possible. So what we can do is we'll just guess, we'll take maybe 5 of them out of the 30, and we'll do the Chinese remainder theorem on those, since we can brute force every single combination for those 5 groups. And as long as the number is less than 2048, there's a good chance that it is the flag. And so that's what you can do to solve it. So here, we're just loading in some stuff. We're going to read the input. The output, this is what it kind of looks like. First, it's a little messy, but it's just a giant array of the 30 primes, and then it's those groups. And so you can see this is a group here. It's just like this, so it's an array of arrays. So first is an array, line 1 is an array, and line 2 is an array of arrays. So we grab those out. I use eval, don't tell anyone. Here is a function for Chinese remainder theorem that I've been using since forever. And this is that nasty brute forcing code. So, like I said, each group has 5 elements. So we're just going to iterate through all possible combinations and do the Chinese remainder theorem and see which one pops out correct. So A, B, C, D, E, F, to E. Like I said, then we're going to do the Chinese remainder theorem. This function takes in 2 arrays. One is the result. And actually, let me back up. So if we remember, what we're going to have is A is equal to flag mod P. Oops. And we'll say A of I and P of I. So we have the result of the mod, and we have the prime that was used in the mod. And our job is to guess what flag is. So the first array is the A of I's, and that's what this is. And the second array is the primes. That's what this is. So we do the Chinese remainder theorem on those, and we see if the result is less than 2048 bits. And if it is, we just print it out. And so I wasn't sure. I figured there was going to be a couple of different responses as we did this. But to my surprise, oops, don't want this in here. There's only one correct answer that pops out, and because of this, we automatically know that this is the flag. So like I said, things were shuffled, but the fourth element, the second element, the first element, the third element, and the 0th element are the correct ones that were modded by the flag, or the flag modded by a prime. So that was it, nice and simple. And the second one was pretty much the same. If we go up, let's go to really loud. The only difference between this one and the previous one is they changed. Now there's 10 elements per group, and we only get 10 groups. But since we're brute forcing, that's still within the realms of brute forceability. We just need to change some things a little bit. So instead of doing 5 element steep, I only do 4 element steep, and I go from A, instead of from 0 to 5, we now do 0 to 10. And otherwise, it's pretty much the same. We can do that. Python 3 solve. And it only prints out one answer. So thankfully, the Chinese remainder theorem, if you use the wrong one, the number just gets super large. So we don't have to worry about any of them. Or the number is incorrect too. That could also be a different thing. And so this one, the first, fifth, and fourth elements were the correct one. So you just take this, wrap it with the dead flag, and submit it. And you got some easy points. The first pwn challenge is one punch. It says hundreds of buffer overflows, hundreds of use after freeze, hundreds of race conditions, and a 10-kilometer ROP chain every single day. We're given a netcat port and a download file. The download file had a bunch of useful stuff. It had the binary. It also had libc, the linker. So very useful. We didn't have to really guess anything about the remote system. If we open it up in Ghidra, we're given a nice, very clean main. It's going to do this init function first, where it's going to do some buffering. It also creates this mapped region, and in here it's just going to request a memory segment, and it's going to put power, get the power into this mapped section. And basically this is a check to make sure that you're not going to call main twice, because we can see for this challenge, basically we're just doing a 2-stage ROP, and so they want you to only run it once. So if we go back to main, it's going to say don't forget your cape. It's going to give us an info leak. So we're going to have a main section elf leak. Then it's going to say, do you have what it takes to be the strongest hero? Then it's going to call vuln, and it says guess not in return. If we look at vuln, it's going to compare that mapped region that I talked about earlier. Basically, this is just a flag to see if you've already called this function before. It should say power, get the power. If it doesn't, it says 2 punch man, lame, and it exits. So we're only supposed to call this once. Then it's going to clear that mapped region so that we can't call it again. And then it's going to do an unbounded gets. All the protections are enabled. Sorry, canary is not enabled, but pi is enabled. So, but that's not really a big deal because we get our info leak right at the main section. So for this challenge, very straightforward sort of CTF challenge, we're going to do a 2-stage ROP. First, we're going to ROP to leak libc, and then we're going to ROP to spawn a shell. There's one trick to, like I said, they did some checks to make sure you can't call this gets function twice, but thankfully it's very easy to bypass. We're just going to, when we start at the end of our first ROP payload, we get to specify where we're going to jump to. We can't just jump back to the start of this vuln function because the string compare will fail. So instead what we're going to do in the main function is we're just going to jump straight into this init call. So we'll jump right here into this, in between this if condition. And so that way init will be called again, because you can rebuffer a buffer, that's totally fine. And it'll do this mmap, it'll reset the variable, it'll do power, get the power, and so that we can call this vuln function twice. To see what that looks like, this is the solve script, all very standard pwn tool stuff. We're going to do the remote. So the first thing, they give us that info leak, so we're just going to grab that out. You just calculate where that info leak is and where the base of the VM map is when you're in GDB, and so that way you know how far away this leak is from the base of the elf. We print those out, we just make sure it's correct. Elf.address should end in 000 if you have it correct. Then we do an offset, we do a pwn cyclic bind, very standard buffer overflow stuff. We need to see how many bytes it takes before we start ROPing, and we can see this here in the vuln function. We can see it's 112 bytes, so it's either going to be 112 or 120 or something like that. Depends on, also this IVAR and RBP on the stack. So we use pwn cyclic to find that. So we see it's FAAB bytes away with pwn cyclic find. Then we do our first ROP leak. So we're going to leak the address of puts in libc, and so that way we know where the base of libc is. So to do that, if we generate a ROP object, we're going to puts the global offset table entry for puts. We could use something else, but puts is just funny. And so that'll give us that address. And since, if we remember, the global offset table is just a mapping in the main elf section that tells us where the functions exist in libc. So as soon as we leak one of them, we know where libc is. Then we jump back, we call init again. Technically, we don't need to do this. Actually, let me just delete that. And then we're going to jump into ROP raw elf address and back to this code. We could just jump from init to vuln, but I think it was easier just to jump into init. Cool. Once we have our payload constructed, we send it over. So it's going to ask us some hero question. We send, all the dummy data to fill up the buffer. Then we send our ROP chain. And then from there, the first response should be the puts call. So we'll get the address of puts in libc. We'll get the leak. We'll pad it to 8 bytes. We'll do an unpack 64. And then we'll set the address of libc address to the correct address. And we'll print it out. And if we get it correct, it should end in 3 zeros again. And then from there, we have a very simple ROP. We jump back into that vulnerable function. This time we're going to ROP, and this is the main ROP call. We're going to do ROP.system, and we're going to search for the string bin shell. This string already exists within libc, so we just need to figure out where it is, and then we need to pass it onto system. And so this will do the ROP gadgets for pop RDI and set up everything we need for a calling system. We have to insert this ROP raw find gadget ret. This is just for alignment issues. libc wants everything to end in, the RSP to end in 0 when you make calls. And so if you add this in, just the stack aligns itself correctly. Otherwise, you'll see it's like some XMMO sort of register that gets mad. So you do this, and everything gets aligned correctly. From there, it should just spawn a shell. So now to run it, we'll jump into an Ubuntu box. Then we'll do Python 3, solve.py, loading gadgets, and there we go. We have shell, and we'll cat out the flag. It says, dead, I wanna be a SailQ hero. I just Googled it. I think it is SciQ. It's a reference to One Punch. The next challenge is Poem Popcorn. We're given a download file and a netcat port. In the download file, it contains everything we need. We're given a binary, we're given libc, we're given the linker, so lots of useful stuff. If we open up in Ghidra, there's maybe 15 functions to reverse. It's really not too bad. The idea behind this program is that you can input, it's kind of like a database, I guess. You can input a bunch of movies and it will store them, and you can input a bunch of reviews for those movies and give the movies ratings and stuff. What ends up to actually exploit this challenge, we're going to be exploiting a use after free. So it's possible to allocate a chunk on the heap, and it'll be used both as a movie and as a review. And then due to the different type differences between these two structures, we can get some leaks. And in the review object, there's actually a function pointer to how for like printing a review, because some of the reviews have a numerical rating and some are only a description, like a string. So they have this print function, and we can overwrite this print function with a win function. And the program actually gives us a win function. So there's a function that already exists that prints out the flag. And so, like I said, our goal is we're going to construct a use after free, and then from there, we're going to get some info leaks to know where things are. And once we have our info leaks, we're going to overwrite that function pointer on the review object to this win function, so that when we print out this review, the win function will be called instead. I'm not going to be covering this in a lot of detail and going through the debugger. I'm just going to cover some tricks that I think will be useful and give an outline. So if you want to try solving it by yourself, this should be a good roadmap, and I'll put the solve script somewhere. So if you actually want to look at how things are done, you can look at the solve script. I think the biggest thing for this challenge and challenges like this is you have to create types. Like this code is kind of nasty. Let me scoot over. I put in the title, create movie, just so I could find it later. But this code is kind of nasty and confusing. And so like the best thing you can do is just come over here. We're going to create a new structure. And you're going to read over the code for a bit, and eventually you'll kind of figure out how this code is laid out. And once we create structures, everything just becomes so much cleaner. So we're going to create a new structure. We're going to call it movie. and it has a size of OX38. And I just know this from playing. You can see there's an OX38 on this thing over here. This is the movie structure. And so, you just play with it for a bit and eventually it comes clear. The first section in this data structure is a char OX20, and this is the title. Cool. The next structure, again, you just get this from kind of playing with it, is a pointer. We don't have the movie type yet. Actually, let's save this. Let me go back. We'll save it. It is a pointer to the next movie. So it is movie star. And we'll call this next. The next one field is a movie star, and it points to the previous. And I got this wrong. This is actually 64 bytes. Then, because it's OX38, and then it actually has 8 bytes after that, so it goes to OX40. The next field is a review. We don't have this yet, so I'm just going to say pointer, and this is going to be to the top of reviews. So this is going to point to a linked list of reviews, which is the second structure in this this program. And the last one is a long, and it is review count. Cool. So now we have this movie structure. And so what we can do is we're going to hit save. When we come over here, it's going to create this, and this is now a movie star. And, oops. Oh, we just give it a name. My bad. Movie star. That's better. And it's just a movie. Cool. And so now that we have type information, this becomes a little bit more clear. We can see it's creating next and previous. We can see review is being set to null right now. Review count is being sent to 0. Again, just highly recommend creating types. You can also create one for review, this review structure, which we'll eventually need to. I'm not going to do it, but basically just do the same thing. You find some functions like create reviews and edit reviews, and from there you can kind of figure out the structure and start giving everything names. Cool. So the actual bug, like I said, we're going to do a use after free. So what we need is to find a place where they're freeing an object, but we still point to that object. So we're using it after we freed it. And the use after free I found was here. So this is the code for delete review. Again, I recommend creating the review object. I did it when I originally solved this challenge just to kind of know what these things are pointing to. But basically this is saying if the next review, if the review is the very last review in a review linked list, it's just going to free it and it doesn't do anything else. And so that means if it's the very last review, it frees it, but it doesn't actually delete the pointer to it. And so because of that, we can still actually go there. And the reason they allowed this was because there's this thing called review count. And so I think the program logic is like if you delete a review, it won't print it out because review count will also subtract by 1. So if you have 3 reviews, review count is equal to 3, and you have a linked list of 3 reviews, you delete the last one, review count is now equal to 2. And even though that it still points to that last review, it doesn't really matter because it's not going to be printed or used in any way. Ends up not being true because there's some code that like iterates through the whole review list chain, and so you can insert stuff at arbitrary places. And so because of that, we can actually use this review even though it's been deleted. So that was that one bug. Otherwise, like I said, the code really isn't too bad. You just kind of go through. There's, these menus for creating, editing, deleting, all that stuff. Like I said, there's this print movies function, and what that'll do is it'll iterate through all the movies, and from all the movies, it'll go through all of the reviews, and on the review object itself, it actually has the code that calls the review function pointer. And there's 2 different function pointers for review. I can see if I can find it real quick. This is taking in a review object. It says enter in a new review, and this is one of those function pointers. And so this is, it'll print the review, and if the review is only a string, and the other one will print a review that also has a numerical rating. So this is one of the function pointers that'll be saved within each individual review object. And so like I said, our goal is to kind of overwrite the function pointer that contains this address. And yeah, that pretty much we're set. So our goal is we're going to create a movie. Then we're going to create a review. We're going to delete that review and make sure it's the very end review, so that element gets set back onto the heap. Then we're going to create a movie. We're going to make sure the movie is the same size as the review that we just deleted. And from there, we should be able to both edit the review and edit the movie at the same time and find differences in how the structures are laid out on stack so that we can kind of print different things that we need, specifically the 2 info leaks. And then we're going to edit the movie title because the movie title overlaps with the review function pointer, and then from there we should have execution. Again, I'm not going into a lot of detail, but basically, I mean, that's our exploit chain. So I'm just going to cover the solve script real quick. Again, if you really want to learn how to do this stuff, I'd highly recommend solving the challenge. You really need to like sit down and play in a debugger. That's how you get good at this stuff. But I'll just cover the solve script real quick so you know of the elements and the different things that might catch you up if you try to solve this challenge. First thing we're going to do is we're going to create a movie. So I just call a movie movie1. Two functions for adding review and deleting review. Again, it's just a bunch of menu and indexing and stuff like that. So we have to pass the menu choice, the movie index, the index for creating, the review length. We get to specify a length for the reviews. If we want to specify a numerical rating, I say no. I don't use the numerical rating for anything. And then the actual review body. And then there's a function for deleting. One thing that makes this a little bit tricky, they're using calloc for everything. So calloc will zero out the heap chunk. So it's like malloc, but it just zeroes it out. Calloc, for some reason, wasn't using the tcache bin. I'm not really sure why. It looks like it doesn't always use tcache. So for that reason, I had to use fast bins. Tcache will only hold 7 elements in the heap. And so you just need to fill it up and then delete them. And so that way you'll read off the fast bin. Again, I'm not really too sure why it wasn't using the tcache bin. But it's not a problem. So basically, we're going to create 5 elements in the 5 reviews. So this is going to malloc. I think they're all OX50 size. And so one thing you have to see is what is the size of a movie object and what is the size of the review object, and make sure that you're creating the same size objects. So we'll fill it up, and then we'll delete a bunch of entries so that the tcache bin is full, and so things will start going on in the fast bin. For the very last 2 reviews we delete, again, you just get this from going through the code. You need to make it, these are the indexes of the reviews we're deleting. If you delete a review that's in the middle of one of these linked lists, it'll do the logic correctly and actually remove it from the linked list. We need to make sure we delete from the very end. And so when we do that, we just do this little swap thing. We do 9876554, and then here we do a 2 and then a 3. That just makes it so that the linked list element is actually the one that's still in the linked list, and it's at the very end. You get this from just going through the code. From there, we're going to create that use after free. So at this point, we have the top element in the fast bin is a review object that is still being used. And so now when we create a movie, the movie will also use that same address as the review. Cool. So this is our juicy movie object and review object that we're creating. And right here, you just need to pass some zeros. This is the size of the review, and then this is some text just so you can find it later when you're doing viz heap. And you just need to make sure, you just have to be a little bit careful with the different types so you don't clobber anything when you do print or when it's like iterating through. We send zeros because when you iterate through the reviews, it looks for that next pointer, and we don't actually know where anything is yet because we don't have leaks. But if we send zeros, it means it's the end of the linked list, and so that way it won't clobber or do anything bad. We add another review. This is just to increment. There's some counter called review count, and so that way it'll start accessing this review. Otherwise, it only iterates up to review count. So we just need to create an extra review. Cool. First thing we're going to do is we're going to, in the menu, you can leak individual movie titles. And so we're going to modify the review such that, we're going to edit the movie title such that it will then allow us to leak the review, and we'll be able to grab a heap address. Again, if you just play with the 2 structures and go through the code, eventually you'll find a way that either you can print the review or print the movie title such that it'll have a pointer in there. And we're able to align it such that we can get a heap pointer. And so from there, we can print out a heap pointer, which is great. So now we have a heap leak and we know where we are on the heap. It doesn't mean we don't have an elf address leak and we don't have a libc leak. And really, we just need the main elf section leak because there's that win function. But once we have a heap leak, we can then do some more fun stuff where we will change the review linked list such that it points to I think we move the linked list for the movies so that it points somewhere else, so that when we print out the movie title, it'll print out a elf section. It'll print out one of the function pointers that exist within the review object. Again, this sounds very complex, but once you're in GDB, like you'll see what you have, what leaks you have, and where you can point the function pointers. It's a lot easier just kind of doing it yourself, which is why I don't want to actually run through GDB and do it. I think you really just have to play with it yourself. But basically, if you just point the address at somewhere, there's already a elf section leak. In the heap, you can print that movie title, and that'll give you a elf leak. And so now we know where the base of the main popcorn binary is. Once we have both of those, we just need to overwrite the print function. So we go back to our review. This time we're going to be editing the movie title. We edit the movie title such that it overwrites the review function pointer, and we give it the win address. And so we're going to do that. We're editing the movie title. We send in some null bytes just to pad, and then we send in that win address. And so now at the very end, this is the function to print all the reviews. Instead of printing that review, it should actually print the win function, and we should just get the flag. So that's a lot. Let me clear this. Python 3. We're running it on remote. So this is it, creating those movies, creating all the reviews. Eventually it's going to do those info leaks, print everything out. And here's where we print out all the movies. And we can see this is what those info leaks looks like. We're printing out a movie title here, and so this is probably it's either the heap leak or the main elf leak, I'm not sure. But we can see this review here, instead of printing out the normal review function, this is what reviews normally look like. It's printing out the flag. So it says, dead when popping corn, remember to clean up. So pretty fun challenge, nice and involved, but I think it was a lot of good techniques, and it was just fun. Overall, we had a lot of fun. Thanks to DeadSec for hosting, and I will see you at the next CTF. Cheers.